Hey, what's up guys? Welcome back to the channel in episode 2 of the best Wi-Fi. Today, we're going to be talking about this. What's in here is the Google Nest Wi-Fi 4-pack. Stay tuned. Alright guys, so in case you missed it, I said it in episode 1 and also posted a a community post. But Costco was selling the Google Nest Wi-Fi, the 4-pack for roughly around $299. That's about $300. That's roughly about $100 off from everywhere else. And I get a lot of questions, like I said, as being a previous network engineer, mainly inside Cisco routing and switching and data centers and CCNP and stuff like that. People always come to me with, hey, what router should I get? Hey, what's the best Wi-Fi? Hey, what do I do with this? Hey, what do we do with that? And we've installed through one of the companies that I work with, and we've installed hundreds, if not thousands, of others, enterprise or prosumer grade access points. But as a home user, like I said, not everyone wants to spend hundreds and thousands of dollars on Cisco AeroNet licenses and Meraki licenses and all this other stuff. So they really know of things they go and find inside Best Buy, Fry, Micro Center, whatever they got around them. So people come to me all the time, hey, is the Google Wi-Fi thing good? Hey, is this good? Is that good? And I really have no idea because I don't really use that. So in searching for getting my hands on one of those, we bought this. So when you buy the Costco Google Wi-Fi pack, it looks like it really comes in a white little box like this, and it looks like what they send you is a Nest Wi-Fi add-on point and this. So it looks like when you buy it, you really get the 3-pack and you get the add-on point. So in case you don't really know how this mesh stuff really worked, this is mainly, there's one like base station, which kind of serves as the router, and then there's other 2 mesh points. And these have become really popular, mainly because people nowadays have been building like 2-story houses, 3-story houses, or basements, and houses are getting bigger, and everyone is using more and more of the internet, especially with connected devices and coronavirus and everyone needing to be connected, Zoom meetings, Hangouts, WebEx, Microsoft Teams, GoToMeeting, whatever. Even kids now these days are all going virtual school and stuff. So not just these days, but I mean, like in the past, there's been more things on the Internet of Things and IoT and all that stuff. So how it's been getting bigger, there's been a lot more demand. So people have been needing more and more Wi-Fi. And the easy way for people to kind of cover their whole house or the whole living space has been to use mesh. Anyways, we'll get to it. So let me go ahead and get this set up and then we'll be right back. Alright guys, and we're back. If it looks like we changed into a new day, it is a new day. It actually took a while to get it set up because when you try to do anything with the baby, it just becomes very difficult. Anyways, the point is that thanks for staying with us. So just to catch you up, we did set it up. We set up the Nest Wi-Fi router base station in the exact same spot that we had the Ubiquiti Unifi HD Nano HD. That's in the exact same spot over there. I'm using the same cable, same location, nothing had changed. All we did was unplug the first one and plug this one in. Okay. Everything else, as we showed in episode 1, is still the same. We'll just go over a quick recap real quick. So this laptop we're using here is going to be the Iperf client. It's connecting via wirelessly to the base station. The Google Nest, man, that's a Google Nest Wi-Fi base station here. It connects to the switch, and everything else here is still the same. Only thing we did is go ahead and change this out. Same cables and same everything. It's the same distance, so clear line of sight from here to there. 21 feet. So we're continuing on here. We're going to see how it goes. Just a key note here. I did put the Google Nest Wi-Fi base station in bridge mode. What that really means is it's not acting like a router. It turns off the NAT and all that fun stuff, and you're really just bridging the access point part of it, which is pretty much what the Unifi Nano HD thing was. So here we go. Let's continue on with the tests. So here is a set of tests that we did in the first one. Let's see if we can kind of do the same test here. So let me get this terminal going here. If I remember correctly, let's go to desktop, and then we ran these commands here. For ease of sake of use, we're just going to start copying and pasting these commands again, and here we go. All right, so while this test is going, let's just go ahead and talk about some of the stuff here. So like I mentioned, we put it in router bridge mode, which kind of just puts it in access point mode. The interesting thing I found out, I don't know if there is any configuration parameters now, but I was not able to find anything where you could easily configure the router. It pretty much comes into like a no fuss, no muss type deal where you plug it in and you turn it on and it kind of figures everything out for you. What I mean by that is I was unable to try to figure out channel settings, transmit power, none of that is in there. You go to advanced settings and all you can really do is put like, what do you call it? Like turn it on bridge mode or NAT mode or router mode. But anyways, looking at this here, auto configuration wise, so we just plug it in. It's running a 5 gigahertz band, channel 149 and 80 megahertz band width. Channel width. So it's pretty much almost the same in terms of channel width. It's going a really wide channel. Apparently there's enough space in here to get the really wide channel around here, but that's pretty much what we got. So as this test finishes up, remember we're taking the best 3 scores on the Iperf test and averaging them out, meaning the highest scores here. So the Google Nest, named as clearly as possible. So looking at this here, wow, it really dropped off here, it looks like. This is a really wide range here. We got 473 down to, I think I saw double digits here somewhere, 88 megabits and then 331. So that seems really strange. I'm gonna run this again just for good measure to make sure we really get the best that it could really do. Maybe one thing you could do is just watch it here. It's still connected, 5 gigahertz band, 80 megahertz channel width. So it doesn't look like it's doing as well as I wanted it to, but hey, like I said, we're literally just letting numbers speak for themselves. It seems to be doing a little bit better. We're in maybe the 297, 287, 329, 249. Nowhere nearly as good as the Ubiquiti Nano HD that we tested in episode 1, but hey, we gave it a fair chance. It's set up the exact same way, like I said, same spot, same cables. We plugged it in. This channel ID or whatever, all that stuff is not configurable. Apparently it just figures it out by itself. And even in advanced settings, it is not there. So anyways, well, we ran it twice, so this seems to be doing better than the first one since all of them so far seem to be in triple digits. Nothing has really changed here except for the access point itself. So let's close some of this and average this out here. I keep deleting that parentheses for some reason. Plus 329, it looks like, plus 312. If I did that right, it looks like the best of 3. Seems to be somewhere around 350 megabits per second. So like I said, that seems really strange. I mean, we did ran it twice. It just seems to be inconsistent all over the place. Maybe we'll try doing the large file, see if that makes any difference here. We changed the, I think this is right. Let me paste this in here and make sure. We'll move on to the large 10 gig file upload test. So for one, All right, guys, and we're back. Looks like the test is slowly finishing up. So it looks like here it's a little bit better in terms of groupings. Looks like we have 3 that are in the low 1 minute and 11 to 12 seconds. So that seems to probably be the best. Let's take those scores here. Well, remember, we're only taking the whole numbers here. So 60 plus 12 is 72, plus the second one set is 60 plus 12 is another 72, plus 60 plus 11 is 71. Come on, guys. We'll divide that by 3. So it looks like in seconds, yeah, so that's definitely better than the grouping side. Like I said, was definitely better than the Iperf scores. So this here probably has limitation with network, or not only networking, but also the computers. Like I said, they're not like super advanced computers or anything. There's just the MacBook Pro and the Mac Mini, a really, really old Mac Mini, but SSD in it. Anyways, the Iperf scores literally just open up a socket so you can really test just better network connectivity. But for people using it for, I don't know, using it for work or transferring large files, or even creators or content creators who are YouTubing and stuff like that, hey, you gotta move your video files around. So this could kind of mimic some type of real world usage. Anyways, moving on to the file download test here. All right, guys, and we're back. Looks like the test is finishing up, so let's check it out. The groupings here definitely seem to be a lot better. Looks like some kind of bottleneck is probably not the networking. If I had to guess, maybe, I'm not sure. We'll have to try to look into that sometime in the near future. But since the grouping is so tight, I think it's probably bottlenecking on either one of the computers or something like that, something else. Anyways, point is, let's look at it. You got 150, 144, 147, 139, 138, 144. Looks like we got some. All right, so if we take the sum of that 98 plus 99 plus 100, divide that by 3, looks like it. That doesn't seem right. Sorry guys, clearly. All right, so that seems more right. So it looks like the down of the file was definitely, seems to be a lot faster. Well, not a lot, but 20 something seconds, that's a lot in network lifetime, right? Network speed. So a lot faster here on this. Okay, that's interesting. So, all right, moving on to the next test. Let's test the concurrent streams here. I know this didn't really do too much. I'm not sure if we're gonna keep this up, if it just keeps performing like that, or we may have to find more devices or something. So let's go back. Let's set that up. Let me go here, get all the iPads connected. That looks good. All right, movie's playing. All right, so we got 3 devices, same as test in episode number 1. And let's kick the test off. $405. All right, so let's take this. All right, equals 456 plus, we had 436 plus, and then we have a 435. All right, let's divide that by 3. So, interesting. So quick recap here, let's go take a look at it. On the Iperf tests, we did 10 runs, and the 3 best scores we averaged, so it looks like about 350 on regular Iperf, and then concurrent streams, we had 3 iPads running, just streaming some movies, looks like 442. On both tests, we noticed that the groupings were really sporadic, meaning we had some in the 400s, some in the 300s. It wasn't as sporadic as like difference of 400 megabits, but could be somewhere around 100 megabits difference. For some reason, it doesn't seem like it could handle that really high throughput or sustain it. I guess what you could do, we could run Iperf Test for a really long time and see how that really works out. But that wasn't part of the test, but just for fun and giggles, let's try that. Iperf on client, as a client, when I just 2 to 15. I think that's time. I think T is the time flag. I don't know. Let's just set this time flag to 60 and see what happens, if anybody's interested. All right, so that's going to be going for roughly around 60 seconds, if I remember those things correctly. But while that's going, we'll talk about this thing here real quick. So like I said earlier in the video, we posted a deal from Costco where you can get this 3-pack and this Wi-Fi point, so you get 4-pack pretty much for roughly around $300. If you were to buy it apparently from the Google Nest store, it would be roughly around $500. So that's really a savings of $200. I'm not sure how much it normally goes for, but it looks like on Costco.com it went for roughly around 400-ish according to Costco. If I remember correctly. So the 4-pack, yeah, so 100 bucks off. I got to sign in to see the price. That's too much involved there. But anyways, so I mean, it seems like a good deal, assuming it stains. We'll see what this Iperf test for 60 seconds turns out to be. See how that really works. Actually, we're not really sure if anybody's really too interested, but it looks like 60-second Iperf test. Socket came out around 410. Maybe we need to add that in here. I don't know. So that's going. I know, like I said, we weren't going to do this too much, but let's do a speed test. And then so this actually goes all the way out to the internet, all right? We're going to test that and see how that goes. And like we did in the first video, we'll run it 3 times. So let me go ahead and get the mesh node set up, since the mesh node is not set up. So here's the mesh node. It's pretty much the same thing. It just doesn't have any RJ45 jacks. But in this case, this can actually serve as a Google Home Assistant type deal. I don't really care about that too much because I don't really use that. But let me go ahead and get this set up, and then we'll go ahead and start testing the mesh wireless performance. So stay tuned. All right, you guys, and we're back. If it looks like it's been a new day, that's because it has been a new day. Yesterday, we spent quite a lot of time trying to figure out why in the world we could not get the mesh set up. And we did everything. We tried to set it up multiple times, set it up multiple places. We thought maybe we couldn't get it. We put it right next to each. Long story short, we decided, hey, maybe it was DOA. We tried a second one. That didn't work. Then we said, hey, let's consult the internet. So what we did was we went around in Google and looked around the internet and tried to figure out what in the world was going on, because we said, hey, this is pretty embarrassing for people who do work on networks and stuff a lot. That seems to be, it's embarrassing that we can't seem to figure out what's going on, right? So we consulted the internet and we found this. Bridge mode only needed blah, 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 blah. Throw it up on the screen. But the main thing you want to take away here is, do Google Nest Wi-Fi and Google Wi-Fi support bridge mode? Yes, but bridge mode will only work if you're using a single Wi-Fi device. If you want to create a mesh network with multiple devices, your primary router or primary Wi-Fi point cannot be in bridge mode. All right, so what does that mean? That means pretty much if you want to use the mesh system, which is the whole primary point of getting Google Wi-Fi, is you cannot use it in bridge mode. You have to use it in normal mode, which is AKA NAT mode, AKA create your own network mode behind it. And that's really weird. I can only imagine a few cases why they would do that. Maybe it needs to create its own network so it can provision its own mesh points, and it has its own internal mesh point network and stuff like that. But I've only seen that on this so far, and all the stuff that I worked with in the past, Aruba, Ubiquiti, Open Mesh, and a bunch of stuff that I work with have not really experienced that, only experienced it with this. So I guess that's maybe a big step or change or whatever what happens when you move into consumer grade stuff, I don't know. But anyways, that's really disappointing, especially for people who just want to use this mesh points. If you did want to do that, there's better stuff to buy obviously, but that's for you. All right, so after all that being said, like I said, it's been a new day. So what we ended up doing was we connected the main router off one of the IP ports off the main switch, and now it's creating its own network, okay? And the extra port that was on there, the WAN port, we connected the Mac Mini Iperf server to. So now that is directly connected to that mesh point. So it's not necessarily routing outside the internet when we do the test. And this mesh base router station or whatever, it's now connected to this mesh point using mesh Wi-Fi technology. So it's an invisible cable, not even a cable. And then this mesh point is connected to this Iperf client, okay? Which is this computer right here. Same thing as episode 1, we're gonna go ahead and run the test, okay? Just wanted to throw it up to you. Everything is the same. Like I said, the cable and everything is the same that we use, same length, blah, blah, everything is the same, except what I just mentioned earlier. So without further ado, let's get up to the test. Equals 207 plus 183 plus 181, divide that by 3, and looks like the average there is 190. 190. Let me make sure we got that right. 190, 207, 183, 181. Yep. All right, guys, so let's move on to the big file test. Just skip ahead if you don't want to pay attention, but we'll speed this up as quickly as we can. It kind of looks like it's gonna thunder like no tomorrow pretty soon. 86.28, I believe. There we go. All right, you guys, we're back. Looks like the test finished up. Remember, this is time in seconds, so we're going to take the lowest 3 values here, and we're going to say equals 86 plus 87 plus 89. All right, divide that by 3. Take the sum of these, take the average of the best 3 values. So let's delete this, and we will head on to the upload test. Here we go. All right, so the test is finishing up, and it looks like, to me, without getting all the definitive numbers, it looks like there's a pretty wide variation here, or variance, as some would say. If I sort this in alpha, so it looks like it goes from 99 seconds to 146 seconds. That's pretty wide variance. That's almost an entire minute of variance you got going on there. So anyways, we said we would take the best 3 values, okay? So that's 99 plus 101 plus 102. Divide that by 3. That looks about right. So that's what we got here. Let's go ahead and I'm gonna set up the 3 concurrent streams, and then we're gonna run this Iperf test again. This should be relatively pretty fast because the Iperf test is really only for about 10 seconds. Where did it go? $64 plus 161 plus 157, and divide that by 3. All right, so it looks like the megabits per second is roughly around close to the same for Iperf. I mean, it's not that much of a difference. 30 megabits, if you think that's a big difference, then sure, it's a big difference. But 30 megabits is not that much of a difference of right here. I know all the people living on the rural say 30 megabits, I would give an arm for 30 megabits. But anyways, that's what's happening here. Let me go ahead and turn off all of the... All right, so let's go over the reviews real quick. If you're just tuning into the results part, we're here. All right, so quick recap of what we were testing. All right, so in the first part, we tested this. We tested the single node mesh or single node router from Google. And then in the second part, we tested the mesh part. So obviously, like I said earlier in the beginning, every time you connect via another hop via mesh, you're gonna be losing performance. Goes without saying. Let's see what the numbers actually said here. So with the single node performance, where that node was wired on an Iperf test, socket to socket, no bottlenecks except for the Wi-Fi, we were able to get roughly around 350 megabits per second on a 10-second Iperf test. Okay, and we did that test 3 times. This was the best score. We did the same test while running 3 iPad streams of movies from Prime Video, Netflix, or whatever, and we got almost an even better score, around 442 megabits per second, and we ran that test 3 times, took the average of the best 3 scores. And then we uploaded a 10 gig file to the server from this computer to the Iperf server using SCP. That took roughly around 71 seconds. And we also downloaded that file from the Iperf test or Iperf server, and it took roughly around 99 seconds. So 10 gig file, while 10 gig file, well, it's 10 gigs, and sometimes content creators or people who do a lot of work or have large files are going to need to move them around, and not everyone is always connected to wired. So to give a general good idea of roughly how it would perform. And 10 gigs is a pretty big file, so who knows. Anyways, then we ran a speed test 3 times, and we took the best of 3. And so we got roughly around 442 down and 456 up. That seems pretty good. And like I said, this is a 2016 MacBook Pro. It doesn't have the latest Wi-Fi 6 and all that fun stuff, but that one is actually pretty good considering it is over wireless. All right, guys. Then we added the mesh. All right, so mesh is where this thing really starts to show the numbers, all right, where it really starts to break away. So on mesh performance, the same Iperf test that we ran here, we're getting best of 10, so we took the average of 3, best 3 of 10, I mean, and then the average is 190 megabits per second. So 190 is, I don't know, significantly less than 350. All right, that's roughly around, I don't know, I can't do math right now, but let's just say that's 200, it's almost 160 megabits slower, okay? 160 megabits, that's almost half. And like we said earlier, anytime you have another hop, you're really losing close to about half the performance, and that seems to show in real life, even with a dedicated backhaul. I'm not even saying this has it, but that's what happens. And even when you do the concurrent streams, now that one of the antennas, assuming it actually does that, has a dedicated, is used for the backhaul, it actually drops off even more. All right, so concurrent streams, 160. Concurrent streams with just the single node router base station, we were getting 442, 160. That is less than half, okay? And then we uploaded the same 10 gig file, and it took roughly around 16 seconds longer, okay? Which is actually not that bad, but we uploaded it 10 times and took the average of the best 3. And then we downloaded that file, and it went to roughly almost the same speed, all right? And then the speed test showed the best we were able to get out to the internet speed test server through the internet was roughly around 155 and 171. So that is actually significantly less than what we got on the wired single node, which is 422 and 155. So even if you doubled 155 twice, you still wouldn't hit 422. So that's what ended up really getting. So let's just wrap this up and talk about this real quick. The other thing to really note here is that I noted here on the spreadsheet. So the groupings in the test were very wide. There was a very big wide variance. Like some of the stuff here, as you can see, took 2 minutes. Some of the stuff is in 1 minute. And I mean, you can scroll through the video if you want to try to figure it out, but the variances were huge, and we took the best of 3. So in the best case that we could get in a real world environment, best case, running 10 times, we took the best 3. This is what the numbers are going to show. But due to its I don't want to say inconsistency in performance, the real world performance of this is actually a little bit less, because when you're using it, it's not always going to be consistent. So make sure you keep that in mind. So this thing, like I posted on the other day of that Costco sale, you get the 4-pack for about $300, which is actually a very good deal considering how much it normally costs. But let's just say, is there a market for this? So there is actually a pretty good market for this. It's all plug and play. The app directs you exactly what to do. It has sound verification, sound feedback, and light feedback. The little Nest Pods have the Google Home Assistant. So there is a very big market for this. The market for this is really going to be somebody who doesn't need the best performance via mesh, and somebody who doesn't want the headache of configuring everything, or doesn't want to get too technical and just wants to take something off the shelf, plug it in, just check next a couple times on a few apps or on the app, and then get it going. And it itself will figure it out. Even in the advanced configuration, we were not able to see if you could set the channel width, select channel, transmit power, VLAN, none of that stuff was there. Okay, so this is a very simple system, but Google has put together a very simple system that works generally pretty well on wired. What I know, we didn't stress test it to like 100 devices or something, but for an average home user who doesn't need all the best of the best and the quick specs and everything, it just needs something reliable. It seems to work pretty well. Like I said, consistency may play an error, but that's really going to be the good market for this. The downside to this is also, 1, the configuration, and 2, the ability for the mesh points to not connect via wired. So this mesh system can only mesh via wireless. All right, I know some other mesh points and stuff like the Amplify, Ubiquiti, Amplify Instant or whatever you can do, and we'll go into some other stuff that you can do. But that gets into something that's a little bit more advanced. So if you want something simple, go ahead and get this. If you want something that is the better performing, just keep watching the videos and we'll throw that up. But is this better than the Ubiquiti Nano HD, which is the current front runner? I would go with the no, primarily because the performance numbers speak for itself. I mean, look at that. Even just wired Iperf performance, it's significantly faster, at least on Iperf, okay? So with that being said, we're gonna wrap this up. Is this for you? You got to figure that out. Can't answer that for you, but it was a good system, plug and play, and it works? Sure. Could there be better systems? Sure. Do you want the headache? I don't know. Like I said earlier, a big thing to take away here also is that, remember, you cannot run this in bridge mode and mesh. You can only run it in bridge mode and then have an access point. So kind of defeats the purpose. Make sure you keep that in mind. Stay tuned for more episodes, and we'll see you guys next time.